I just wanted to hop on here and show you a video of what you just did and give you some commentary to be sure you got what you needed to get out of this lab. This new unit that we're doing is called Gas Laws, and it's all about how gases behave in our world. So our main variables that you're going to be talking about and using in your calculations are going to be pressure, volume, and temperature. And we'll just talk about those relationships that they have with each other. We'll also throw in moles in there, and we'll do some stoichiometry with it. But for today, you just need to kind of witness how pressure and volume and temperature are related and how the gases behave in those variables when we change them. So I'm going to play this video and I'm going to pause it every once in a while and give you some commentary. Uh-oh, it's freezing. There we go. Okay, so he's heating those cans just like you did on the hot plate. You can see the hot water vapor coming out. So you can see that steam coming out. That's water vapor, right? Because the temperature is very high in the can. They're full of a little bit of water. So notice he was talking about the temperature. The water is boiling and it's caused those particles to expand. And we talked about that in Unit 2. Like, you know that those gas particles spread out and kind of bounce all over the place. So the higher the temperature, the more volume those gas particles pick up. That's cold water. Did y'all do that in lab? Okay, so when they put the hot can with the warm, hot gas in the cold water, that volume decreased. It imploded on itself. So there were several things going on. When you cool the temperature, right, just like you know what happens to a gas, if you cool the temperature, those particles settle down and they decrease in volume, okay? So that also causes a decrease in pressure. Now, it's not the decrease in volume from lowering the temperature that causes the can to crush. What causes the can to crush is the lower pressure inside of the can is now lower than the atmospheric pressure. So the outside pressure is so much greater than that inside the can because you cooled those gas particles and they condensed down, that the outside pressure crushes the can in. Okay? Then, when he pulled out the can, and when you pulled out the can in your experiment, all this water gushes out, way more water than you had in there. So why did that can fill up with water when it crushed in? They're nerds. Because it happens. Okay, so the host right there where he says nature hates a vacuum, that's actually pretty key in what happened. So it's not the can sucking up the water, okay? It was that lower pressure inside the can and the greater pressure outside of the can pushes that water inside the can, okay? So anytime you have a lower pressure somewhere, that's a vacuum. So that was exactly what you did today, probably just with less nerd factor. So I want to show you another video that I have pulled up, and this is a tanker, like a huge tanker, and they let this hot gas cool inside of this tank without venting it or, preparing it to do so. So watch what happens. This one's pretty cool. Okay, so it was a hot gas in there, right? And when you have a hot gas, your particles are spread out, you have a high volume, you have a high pressure. We'll talk about why in a minute. And then it cools. So what's going to happen when that gas starts cooling down, right? It's going to decrease in size and volume, and it's going to decrease in pressure. And so then you're going to get a lower pressure inside of this tanker than the outside atmosphere. Oh, it already did it. My computer's freezing. It shows it again. Watch. Okay. So I'm sorry that didn't show you very much, but hopefully you have a pretty good grasp, sort of, on how temperature and, look, there's the Daily Dowell. Temperature, pressure, volume kind of all interact. My lights went out. Talk about nerd factor. I should be on that show with those guys. Anyway, hopefully you have a good understanding, and I'm going to put a few other videos in a PowerPoint, and you're going to do some, I just pinged myself. I cannot get it together today. Anyway, check It's Learning. I'm going to have more for you to take notes on.